Okay, let's take a look at our lesson on hyperbolas. So on the past few lessons, let's just kind of review what we've done so far. We've looked at ellipses. And so let's just remind ourselves the ellipses, their formulas were basically like a fraction with x in it over a squared or b squared, depending on what kind, a fraction with y. So those were added together, right? These fractions were added together equaling 1. So that's what we had done last time. And a circle is a bit more simple. That's there aren't any fractions and it's equal to r squared. So today the hyperbola is similar equation to the ellipse. The only difference is they're being subtracted. The two fractions are being subtracted, and that's how you can tell one from the other. So let's look at the differences. Okay, so we also have a horizontal. We've got a horizontal hyperbola, and we've got a vertical one. The horizontal one has our I just call these little pieces. These hyperbola pieces open up along a horizontal axis. It doesn't necessarily have to be the x-axis, but it needs to be a horizontal axis. A vertical hyperbola, this one those will open up along a vertical axis, either the y-axis or a vertical axis. So that is how we tell them apart. How do we know? How do we know which is which? What we're looking for is the positive fraction. Okay, so if we look at this positive fraction, the positive fraction has a y in it. So that means it's going to be a vertical hyperbola. Over here, this positive fraction has an x in it. So that means it's going to be a horizontal hyperbola. That's how we can tell them apart. That's how we can tell where to draw the hyperbola pieces. They look like two little parabolas facing away from each other. I know that that's what they look like. They're not two little parabolas facing away from each other, but that's what they look like. They actually are one whole. That's a hyperbola. And so there are some peculiarities with hyperbolas that ellipses don't have. For example, hyperbolas will have a set of asymptotes. These asymptotes go through the center. So let's remind ourselves the center is HK, right? That's the center. And so this would be the center right here in the middle. And our asymptote we write, my favorite equation of the line, which is, y minus y1 equals m times x minus x1. Okay, we always use, for our y1 and our x1, we always use h and k. That's just what we do. When we write the equation of the asymptote, we use h and k. The slope we get from the denominators of the formula when it's in standard form. That's another reason why it's really important to get the equations in standard form. You can read a lot of information out of them. So you can read the center, h and k, and you can read the slope of the asymptotes. So let's just kind of focus on this for just a moment. So the slope of the asymptotes is either going to be b over a or a over b, depending on what kind of hyperbola. So let's look and see if we are going to be able to figure out which is which. So thinking back to slope, which is rise over run, think about rise being the y and run being the x. Then you won't ever get mixed up. The top number, this top number, is always the number under the y fraction. Okay, it's always the number under the y fraction. If you look right here, it's the number under the y fraction, which happens to be b squared. Over here, It's the number under the y fraction. In this case, happens to be a. So the top number of the slope is always the square root of the number under the y fraction. The bottom number of our slope is always the square root of the number under the x fraction. So I have the x fraction right here and the x fraction right here. The x fraction is going to give us the number in the bottom of the slope, the square root of the number in the bottom of the slope. So I'm going to pause there for a second and make sure that's pretty significant for us, because we are going to have to write, not only will we have to write the equation of the hyperbola, we also will have to write the equations of the asymptotes. Now, which formulas are going to be given to you? Okay, that's always a good question. You're going to get these formulas right here. The formulas with the equation and the asymptotes. You're not going to have to memorize those two sets of formulas. We will give those to you. What you will need to memorize is the equation that goes with the focus points. Just like in the other scenario, this equation right here, which goes with the focus points, that you will need to memorize. Okay, and I've indicated on each lesson which things you need to memorize and which things you don't. So let's compare and contrast this focus equation to the focus equation from ellipses. You remember the focus equation from ellipses looks almost exactly like that, right? But it has a subtraction sign in it. It's a squared minus b squared equals c squared. The focus equation for the hyperbola is a squared plus b squared equals c squared. So they're just slightly different. How do I remember which is which? I will just tell you how I remember which is which. What I do is I look at the whether we're adding or subtracting the main function. So right here, this is subtraction. Since that's subtraction, my focus equation is going to be addition. Okay, they're always opposite. Since that's subtraction, my focus equation is addition. If I look back at the ellipse equations, same scenario. Okay, if this is positive, this main equation is positive, my focus equation is going to be negative. So that's how I remember which goes with which, because the focus equation really should not be that hard to memorize. It looks just like Pythagorean theorem, which y'all have memorized for like years, right? Should not be that bad. It's just figuring out which one goes to which. All right. Okay, so that's an overview of the equations. Now let's kind of focus in on the graph of a hyperbola. Unlike the ellipse, where, remember the ellipse, A is always the biggest number? Remember that? A is always the biggest number. That is not the way hyperbolas work, and that tends to be confusing to students sometimes. A is not the biggest number for hyperbolas. A simply goes with the positive fraction. Let's just make ourselves a little note. Okay? A is not necessarily larger A is with the positive fraction. The positive fraction carries the weight of everything that happens with the hyperbola. The positive fraction is the most important because the positive fraction tells us which way the hyperbola pieces is going to open. If the positive fraction has the x in it, it's going to be a horizontal hyperbola. If the positive fraction has a y in it, it's going to be a vertical hyperbola. So that gives us a big amount, an important amount of information. So when we're looking at our diagram, A is actually this distance right here. This is A. The distance from the center to a vertex is A. Okay? B is the distance from the center to this point out here. And so let me tell you what, when we graph these little guys, typically what we'll do, or what I do, is I draw a little box. I draw a box between when we were working with ellipses, this point right here would have been called a co-vertice. But this isn't really a vertice because it's not attached to anything. It's just an alternate point. So what I do is I draw a box. I would recommend you do the same. When we graph in a moment, we're going to draw this box that connects together the points that are A distance and B distance from the center. And that little box is quite helpful, and we'll talk about that little box when we graph. But that little box is quite helpful to us in graphing. So A is the distance from the center to one of the vertexes. B is the distance from the center to, then this is called the conjugate axis, to the end of the conjugate axis. The conjugate axis is this axis right here. The transverse axis is the main axis. Those are just the names. The transverse axis is the axis that the hyperbola pieces rest on. And the conjugate axis is the alternate axis. The last letter is C. And so C is the distance between the center and the focus point. That's C. And that's a focus point. The focus points are nestled inside each of the branches of the hyperbola, kind of like the focus would be in a parabola. You know how parabola would be kind of like inside the little parabola pieces? This is the same kind of scenario. It's actually nestled inside each of the focus pieces. Okay, so I'm going to pause here for a second. That's the overview of the new formulas we're going to be working with and the makeup of the graphs, how we graph them. Okay, are there any questions so far? Okay, so what we're going to do is we're going to start like we did with the previous lessons. We're going to first take some information and we're going to write a hyperbola equation. Then the next one question is graphing. Then we'll graph. Okay, so let's see what information we have. We have the standard equation of the hyperbola with the center -2, 4. So this is h and this is k. H and k. Okay. I'm going to start graphing it because that's what I do. It just helps me visualize what kind of hyperbola this is going to be. My center is at -2, 4. So right there is my center. Okay. A vertex at 6, 4. 1, 2, 3, 4, 5, 6, 4. This is one of my vertexes. Now a vertex is what the hyperbola piece rests on. Okay, that's what the hyperbola piece rests on, is a vertex. So as I'm looking at this, this is, they're spaced horizontally away from each other. That means that this is a horizontal hyperbola. Okay, that's what that is, because those are oriented horizontally from each other. Okay, what else? What other information can we get? Let's see. So this distance between the center and the vertex 1, 2, 3, 4, 5, 6, 7, 8. That distance is A, and A is 8. Okay, great. I have a lot of information so far. So let's kind of, let's write what we have so far. So I have h, which is -2. Now, since this is a horizontal hyperbola, the x fraction is the positive fraction. It comes first. So this is going to be x minus a -2 to be x plus 2 squared over, and we said a was 8, so 8 squared minus y minus 4 squared over, we don't know, is 1. Okay, were we able to get most of the information from just that little bit of telling us about the center and the vertex? We were able to get most of the information. What we're missing now is b squared. We don't know what that is. What is our clue? Where our clue is this slope right here. Okay, this slope is our clue. So let's think about this. So this slope is either a over b or b over a. It's one of those. Well, let's figure out, we know it's a horizontal hyperbola, and we know that the number under the x is a. So that means that this has to be b over a. Okay, that's what that is. A 1/2 is b over a. Okay, so what do? We're going to use a ratio. We're going to use a ratio to determine b. That's what we do when we have our slope. We've got one of the asymptotes there. We've got a slope, so we're going to use a ratio to determine b. So I have 1 over 2 equals b over a. That's our ratio. Now we know what a is, right? We know what a is. A is 8. So I've got 1 over 2 equals b over 8. Now it's just a matter of solving my ratio, my proportion, and so I would cross multiply and get 2b equals 8, or b is 4. Okay, so b is 4, so that would be 4 squared. So I'm going to pause there for a second. How are we doing? Does everybody understand how we found b? We used the slope as a ratio. Okay, so now let's just clean up the formula. Let's just make it look proper. Okay, so this would be x plus 2 squared over 64 minus y minus 4 squared over 16 is 1. Okay. All right. The next problem, let's go to it. We're going to practice graphing these little guys. Okay, of course, it's in our formula is in general form. We need to put it in standard form. We've done this several times before. The process doesn't change. We group the x's together. So x squared, let me just make this a little bit bigger. So I've got x squared, if I could write, minus 2x. Then I've got negative 4y squared plus 16y. Then I've got a 19. Okay. So here we go. On the x's, the leading coefficient is 1. The number in front of x squared is 1, so I don't need to do anything. I just can go ahead and go for it. So I've got half of 2 is 1. 1 squared is 1. Plus 1. Plus 1. Okay, the y's not ready to complete the square yet. I've got to that. Now this is where it gets tricky. There's sign issues here. When we're dealing with the hyperbola, one of the x squares or y squares is going to be negative. You have to factor out a negative. You don't have a choice in a hyperbola. You're always going to have to factor out at least a negative. At least a -1, if not, like in this case, a -4. So I'm factoring out a -4, which means the sign of b changes to negative. Right? That's what happens. When I factor out a negative, that middle sign changes. And that's probably one of the most common errors that I see is students forgetting to change that middle sign. So please be careful. So half of b, half of 4 is 2, 2 squared is 4, plus 4. But I'm not going to add 4 over here on the right. What am I going to actually do? Subtract 16. I'm going to subtract 16. Very good. Subtract 16. Because I factored out a -4. So I've got x minus 1 squared minus 4 times y minus 2 squared equals, let's see, 19 plus 1 is 20, minus 16 is 4. Is that proper form? Nope. What is it supposed to equal? 1. So I'm going to have to divide everything by 4. Have to divide everything by 4. So I've got x minus 1 squared over 4 minus, let's see, 4 divided by 4 is 1. So, okay, so there's my formula. In this case, is it horizontal or vertical? Well, the x is the positive one. That means it's horizontal. Okay, that x is the positive fraction, makes it horizontal. A is 2, b is 1. Let's use our little formula. A squared plus b squared equals c squared. So what is that? 5 is c squared. So c is plus or minus root 5. Okay, we can read the center out of our formula. The center is 1, 2. All right, how are we doing? Okay, the rest of this we're going to build on the graph. We're going to go to the graph and we're going to build it off the graph. So let's go to our graph. And our center is 1, 2. So let's put our point right there. A is 2. That means I go 2 spaces to the right of the center and 2 spaces to the left of the center. Okay, those are my vertices. B is 1. That means I go 1 space up and 1 space down from my center. Now this is where I draw my box. I would recommend that you draw the box. So we're just going to connect all of the vertices and, well, not co-vertices, but all of our pieces together. And we're going to draw our asymptotes. The asymptote goes from the center through the corner of the box. So from the center through the corners of the box. That's really the benefit of the box. Okay, from the center through the corners. Okay, well, I know it would be better if I got my little ruler out. I love that little ruler. Okay, so, and it's off. Okay. So why is that good? Why is that good? The box, the reason the box is good is that it helps us place the asymptotes where they're supposed to be. You could actually count the slope if you wanted to off of this, because this is a everything crosses at the crosshairs, so you could actually count the slope off if you wanted to. We're not going to do that, but you could do that. And it also guides the hyperbolas, how we place the hyperbolas. So the hyperbolas start at this vertex and they move out and try to skim along, just like remember when we were drawing all of our other graphs, kinds of graphs with that has little asymptotes. The figure wants to blend along and wants to skate along the asymptote. So that's the great thing about the box and the asymptotes, is it kind of shows us exactly how to draw the little hyperbola pieces. Okay. Okay, we've got it graphed. Now we just need to write down our parts. So our vertices, that's these points right here where the hyperbola piece is sitting. So that would be 1, 2, 3, 3, 2. And negative, negative 1, 2. Those are my hyperbolas, or my vertices of my hyperbolas. The focus points are just like when we were doing ellipses. They're from the center, and we're going to add and subtract C. So it's 1 plus root 5, comma 2, 1 minus root 5, comma 2. And I'm going to write that together. So 1 plus or minus root 5, 2. That's the point. Now, root 5 is a little bit bigger than 2, right? Because root 4 is 2. So it's a little bit bigger than 2. So I'm going to graph my focus points. I'm going to go a little bit bigger than 2, which would put it about right there. And a little bit bigger than 2, which would put it about right here. We're a little bit bigger than 2 on either side of the center. Remember, everything is grouped around the center. It's a big deal. The center is a big deal. All right, equations of asymptotes. Okay, we do the same thing every time. It's y minus y1 equals m times x minus x1. My y1 and x1 are the center. So y minus, what is my center? 2 equals plus or minus, we're going to leave that for a moment, that slope, x minus 1. All right, if you know the center, you can almost completely write the asymptotes. We always write them together like that. Please don't distribute and combine like terms and write two different ones. That's a lot of extra work for really nothing. Okay, so just leave them bound together, because there's one asymptote that has a positive slope, one asymptote that has a negative slope. So remember, the asymptotes are either A over B or B over A. That's what they are. Okay, I'm not going to worry about what's A and what's B. I'm just going to look up there on my formula. The y, what's under the y, the square root of what's under the y goes on the top. The square root of 1 is 1. What's under the x, which is a 4, the square root of that goes on the bottom of my slope, and that would be 2. Now, if you don't like remembering that, you could actually come up here and you could count. If we start from the center and we rise 1 and run 2, see, we go rise 1, run 2 to get to this point right here. It gives us a positive 1/2. I mean, it's 1/2. Either way you look at it, whether you count it off of the graph or whether you read it off the equation, it's going to be 1/2. Our last task is to write domain and range. Now, I just want to make it clear, this stuff in here, the stuff between here, is not part of, it's not part of the hyperbola. It's empty. It's completely empty. You're not going to include that in the domain. The hyperbola are those little blue curved things, right? That's what they are. It's not that whole picture. Think of the middle part as like scaffolding. It's scaffolding to support the hyperbola, the way that it's built. So it is definitely not included. So when I am looking at my domain is going to be negative infinity to -1, and -1 is included. It's actually, you know, a point. There's a vertex there. And then I don't have anything included in the middle. And then I get to the other vertex. The other vertex is at 3 and goes to infinity. The domain does. My range is -infinity to infinity. Okay.